Hi everyone and welcome to another webinar by Encora Elements. Today we have Avanti who will be speaking to us about Snowflake. She is a software engineer specializing in QA with 8+ years of experience in ETL, manual database testing, web services, mobile integration testing, and Scrum mastering. She is also known for a quick learning ability and enthusiasm for adopting new technologies. Currently, she is focusing her skills on Power BI, DevOps, and actively engaging in Power BI migration testing. Her goal is to leverage this experience to enhance data visualization and analytics capabilities in all her projects. Few fun facts about Avanti. She really enjoys singing and exploring new places. She also enjoys watching cartoons like Tom and Jerry. All of us remember Tom and Jerry and the fun we used to have as kids, and it always makes all of us happy. She also loves playing badminton and has even competed at the district level. So, without wasting any more time, I'm going to hand this over to Avanti, and she will take us through the rest of the session.
Yeah.
Over to you, Avanti.
Thank you, David. So, hello everyone. I'm Avanti. So, as David introduced about myself, I'm going to have a session today on Snowflake. So, the topic is about unlocking the potential of Snowflake. So, I'm very glad to have a session by NPTEL, providing to NPTEL. So, I'm really very glad on that. So, let's go into the session now. Coming to, let's have, see, first we'll go with the table of contents over here. So these are all this is the index of the Snowflake, which I'm going to have a session today. Introduction, key features, data architecture, functional architecture, login, warehouse, database, schema, table and columns, load data from files, extra. So this is how these are all the topics I wanted to explain. I mean, have a brief discussion on this. So next, coming to the other thing, coming to introduction. Let's go to the introduction of Snowflake today. Actually, Snowflake is a cloud-based platform where the business stores data and analyze their data. It is designed to handle large quantities, large amount of data and small amount of data efficiently and quickly. Here, which helps in managing, analyzing the data more flexibly at lower cost. So it is popular because it scales easily with business needs and offers strong security features. See, overall, Snowflakes makes it easier for companies to make sense of their data and use it in smart decisions. So here we have actually Snowflake supports cloud storage from client side as well. It means that client have can have the data in their clouds and they can load into Snowflake by referring the location. As of now, Snowflake supports three clouds, that is AWS S3, Microsoft Azure, and Google Cloud Platform. So for now, Snowflake is supporting these three clouds. So this is about the introduction to Snowflake. Coming to the next content, that is key features and capabilities of Snowflake. Let's discuss about the key features and capabilities over here. So we have cloud native architecture. Actually, Snowflake operates entirely in the cloud, leveraging the scalability and elasticity of cloud infrastructure. That's what I discussed before in the introduction, saying Snowflake supports three infrastructure, that is AWS, Azure, and Google Cloud. Here, coming to separation of compute and storage. Here, the unique architecture separates storage and compute, and also this enhances the performances and optimizes the costs over here. So next thing, unified platform. It integrates data warehousing, data lakes, and big data analytics in one platform, simplifying data management and analytics workflows as well. Concurrency. So coming to the concurrency and performances, here it supports high levels of concurrent queries with automatic scaling of resources and also query processing for fast performance. So this is how the concurrency and performance works over here. Coming to the security, security provides features including end-to-end encryptions, role-based access control, that is RBAC, and compliance certification, for example, HIPAA, GDPR. So these are the strong security features, including end-to-end encryption over here. Next, coming to the data sharing and collaboration. So here's secure data sharing across organization and enables collaboration on data analytics projects. So it facilitates securing the data sharing across our organization of data analytics projects. Coming to support for structured and semi-structured language, it handles, handles diverse data types, including structured tables, semi-structured, that is JSON format, XML, and unstructured data efficiency, that means raw data. So raw data also it supports for structured and semi-structured. Coming to integrated ecosystem, so seamless this with actually when the data is loaded, when the data will transform the data through ELT or ETL process. So we can analyze the data, analyze the loaded data, particularly the loaded data can be analyzed. After the analyzation of the data, we can develop using BI tools, data science platform, and data integration tools for enhanced analytic capabilities over here. So this is a more chance for this Snowflake. And time travel and data versioning, it provides features like time travel, data versioning, allow users to access and restore data from different points in time. Automatic management, here tasks such as performance tuning, resource management, and data replication reduce administration overhead as well. This is about the key features and the capabilities of the Snowflake. Coming to the next content, that is data architecture. So let's discuss about the architecture of a Snowflake over here. Snowflake architecture is about making data storage and analysis in the cloud. Cloud powerful, fast, and accessible for business in of all sizes. Coming to Snowflake uses a central data. So actually it uses a central data repository for persisting data that is accessible from all compute nodes in the platform. Here Snowflake processes queries using massively parallel processing, that is MPP, compute clusters where each node in the cluster stores a portion of the entire data set locally. So this approach offers the data management simplicity of a shared disk architecture, but with the performance and scale out benefits of a shared nothing architecture. So this is about this Snowflake data architecture. Coming to this unique architecture of, actually Snowflake architecture consists of three key layers over here. One is database storage, query processing, cloud services. See, if you see the diagram over here, see, this is the database storage, query processing, cloud services. Database storage contains the databases, query processing contains the virtual warehouses over here, cloud services contains the authentication and access control, infrastructure manager, optimizer, metadata manager, and also the security over here. Let's discuss in detail about these three key layers over here. Okay, let's go to database storage. Database storage in Snowflake will be having first a part integration. Snowflake integrates with cloud storage. So cloud storage, as I have discussed before, this AWS S3, Azure Blob Storage, and Google Cloud for scalable and durable data storage over here. We need to follow the format to transform the data or to move the data to Snowflake stage. Here we are following the format. Data is stored in a columnar format, optimizing query performance by retrieving only necessary columns. Here we need to follow As per the client, if the client provides whatever the columns to be transformed, so we need to retrieve only the necessary columns from the cloud storage, and then it should be formatted before transforming the data or loading the raw data. First we should concentrate on the format. So once the format is done accordingly, data is stored in a columnar format, then it can be retrieved only in with the necessary columns. Segmentation automatically segments data into micro partitions. So there will be many micro partitions like incremental loads. So there's all sub micro partitions for efficient querying and parallel processing. It follows history and incremental processes based upon the data size, and if it is a large data, it follows the micro partitions. Internally it divides the data into micro partitions, and then it's load to the database. This is how it works in the data storage. So types, what are the types supported? I mean, supported for this data storage or semi-structured, unstructured data format, and it also supports structured, that is tables. Semi-structured means JSON, Avro, XML. So a CSV file, all these are semi-structured. CSV file, DAT file, all these come under semi-structured. Unstructured data format, in the sense it's a raw data, we need to transform it as per the client requirements. So this is about the data storage. Next, coming to the management, handles compression, indexing, and storage optimization automatically. Benefits: scalable, performs well with large data, supports diverse data types, and ensure cost efficiency with pay as user go pricing. So next, coming to the query processing. Here the query processing, submitting queries, I mean, user writes SQL queries to retrieve specific data or perform operations on data sets stored in Snowflake. When we transform or load the data from a particular cloud service, so then the data set stored in the Snowflake, so we use a query processing method, that is virtual warehouse. So here we need to execute SQL select statement that require compute resources. I mean, it will retrieve the data uh, from tables and views. So performing DML operations such as updating rows, delete, insert, update, loading data into tables. So if we want to load the data into tables from a particular Snowflake stage or Azure blob storage or anything, from any cloud services, so we need to use copy into a query for loading the data into the tables. Unloading data from tables, so we need to use the same thing for unloading the data from the tables. If we want to unload, I mean, it's nothing but if we want to delete it or if we want to remove the data from the tables, we need to use copy into, and we need to give location in the place of table. So this is how we unload the data from the tables. Parsing: Snowflake first analyzes the SQL query and understand its structure and intent. So this is about that. Optimization: here the query optimizer then decides the most efficient way to execute the query. It considers factors like data distribution, available compute, resources, and query complexity. Next, coming to execution. So the optimized query is executed in a virtual warehouse, that is computer cluster within Snowflake. This warehouse dynamically adjusts resources based on the query's needs. Parallel processing. Let's discuss about the parallel processing. Divides the query into smaller tasks. That's what, which I have discussed earlier. Parallel processing is nothing but it divides the query into a subtask and process them simultaneously across multiple nodes. If we have a large data set, what happens? It will divide internally by itself and process them simultaneously across multiple nodes. That is called parallel processing. This speed up query execution, especially with large data sets. So this is about the query processing. Next, coming to cloud services. The cloud services is a collection of services that coordinate activities across Snowflake. Here we have a different components of Snowflake in order to process user requests from login to query dispatch. Here the cloud services layer also run on compute instances provisioned by Snowflake from the cloud provider. Managed in this layer include authentication. We need authentication to have to manage the services and infrastructure, metadata management, query parsing, and also the access control. So we need all these to have to participate, or these services tie together all the different components by managing all these services. So this is what about the cloud services. Next, coming to the other content, that is functional architecture of Snowflake. Let's discuss about the functional architecture. At functional level, to access data from Snowflake, the following components are required over here. So we need to choose proper roles after logging. Virtual warehouse known as warehouse in Snowflake to perform any activity. So first we need to choose virtual warehouse, database schema, database, and specific tables and columns. Everything should be in a sequential order. Snowflake provides the following high-level analytics functionalities: data transformation, supports for business applications, business analytics reporting BI. So business analytics reporting BI plays a very important role in the Snowflake functional architecture. Data science, data sharing to other data systems, and also data cloning. So this is about this, which provides the high level analytics functionalities in the functional architecture. Next, coming to the diagram over here, the symbol of settings as in each block can be referred as a warehouse, and XS, double XL, XL, L, S as sizes of warehouse required to perform different operation over here. If you look into the diagram over here, see structured and semi-structured data has extra small data load over here. Here I'm coming to data transformation has small. Next, secure sharing and collaboration coming follows with the company's private data center, and this data exchange can be done with employees, then go to company's business ecosystem. So this is how it is providing over here. And finance app as a medium size, data science as an extra large data set. Coming to marketing analytics plays a big data set, large data set, that is XXL, extra double XL. So this will follow double XL data set over here. So based on the requirement on usage, the size of a warehouse can be increased or decreased based on the data set and the usage, based on the large data set, small data sets, semi structured data, data transform, everything based on the data set where warehouse can be increased or decreased. Even it can be converted from single cluster to the multiple cluster as a parallel processing, because if the data set is very large, we need to follow the parallel processing, which can be divided into multiple nodes and run parallelly. Then it internally divides into the subtask and learn and divides single to multiple clusters. So this is how it works. Next, coming to the next content, that is Snowflake login. Here, actually, Snowflake is a licensed data platform. It uses the concept of credit to charge to clients. So, however, it provides a 30 days free trial with $400 credits for learning purpose. So it's based on the requirement and everything. So using the following steps to get a free access to Snowflake for 30 days for learning purpose, here are few steps. Open the URL and click the start for free at the right corner of the page. So this is highlighted. If you look into the diagram, it is highlighted in the red. So start for free. Just click on that. Then you will go to, it navigates to the registration page. where the user needs to provide the details such as first name, last name, email, company, and country. After filling the form, click the continue button. Next, it asks to choose the Snowflake edition. Select the edition because based on the functionalities, we want to perform and choose cloud provided. So as Snowflake only supports AWS S3, Google Cloud Program, Microsoft Azure, we can select any of them as per our requirement. So provider based on the requirement. Check the terms and condition box and click the get started button. Now, coming to user will get a message saying that an account creation is in progress and an email is sent to your address, email address, provided email address as shown below. So this is how, check email inbox once user receives an email, usually within 2 to 3 minutes, click to activate button. So it will navigate to Snowflake page where user requires to set up username, password. These credentials will be used to log into Snowflake. So here is an URL provided in username. So in this way, this is the example of the URL. It is a user specific URL to access Snowflake at cloud. If user wants to work in Snowflake, use the individual URL and log in. So this is how. Go to the email received and go to the browser and navigate to the URL. It will navigate to the login page, provides the username and password that you will have set during registration. Finally, click the login button. So the following screenshot also, I have given the example for every point. So a successful login navigates to the Snowflake data platform. Users can see their name at the top right corner as shown. I'll show in the next screenshot. Along with the name, they can be seen with the role is assigned to them. At the top right corner, there are some icons like databases, shares, data marketplace, warehouses. All these can be visible once we log in. In the left panel, the few database schemes are provided by Snowflake for hands-on demo. So this is how it will provide. The blank white screen adjacent to database details are called worksheets. So at the bottom, there is a result panel. So this is how it looks like. Account. So under account, it will show the logged in name. Now, who is going to log in? So for example, I have logged into the account. It will show my name as Avanti over there. If whatever the name I'll provide, it will show over there. Highlighted red highlighted color. This shows, see here, database, shares, marketplace, warehouse, worksheets, new worksheet. If we want new worksheet, we can click over here. And if we want to find any database objects, so we can search for it, run results, queries. If we want to run the queries, we can enter the query over here or create a query to run the query. So we can see the results over here. This is about the Snowflake UI part. Next, coming to Snowflake Warehouse. So what is Snowflake Warehouse? First, we need to create a Snowflake warehouse. Log into the Snowflake using unique URL, click on warehouse. So warehouse present at top ribbon as shown in the following screenshot. So once clicked on this warehouse, it navigates to the next screen saying click create button. Create over here. So with representing with the plus icon over here. So on clicking create button, it opens the create warehouse dialog box. So the following field should be name, size, set, auto suspend to 5 minutes. 5 minutes. So whatever, as per your requirement and as per your understanding, you can set whatever you want. Name can be given and size, so small, big, everything. So it's based on you. Then click on finish button. So on clicking the finish button, once the warehouse is created, user can view in the list as shown in the C. I have created test underscore WH over here and size is small. So auto suspended, it will suspend automatically within 5 minutes. So this is how it will create over here and it will show us all the details. Size, what the size we have given, running, query, everything. So this is about the warehouse. Next, coming to the Snowflake database. Here, the Snowflake database, working with databases using Snowflake's UI, plays an important role. All data in Snowflake is maintained in databases itself. Each database consists of one or more schema, which are logical grouping of database objects such as tables and views. Snowflake does not restrict the limits on the number of databases. You can create schemas within the databases or objects within the schema. Let's see that. See, login to the unit, click databases. Click the databases at the top of the ribbon as shown in the screenshot. On clicking the database, click on create button. So representing the plus icon over here. After that, it will take user to the create database dialog box. Enter the database name and comment. Then click finish button. So see here, the database is created successfully. See test underscore DB creation time owner. So it will represent all whatever we have created. Now use the create button for creating a new warehouse. User can clone, database after creating the database, we can clone the database, or we can delete the database or drop a database. So if we want to clone a database as well, by selecting a database and clicking clone button, it pops up a clone database dialog box to enter some information like name, source, comment. So what table we want to clone, or we have to give all the details of that particular table. So name, source, comment, and everything. After entering those details, click finish. So it will clone the data. Next, coming user can see another database is created and it will be visible in view panel. User can also delete a database by selecting a database and clicking on drop button. It pops up a dialog box for confirmation over here. So click S for deletion, else no. If you want to delete, you can click S or else no. This is how it acts. So this is about Snowflake database. And if we want to create a database, we can write the query like create database, whatever the name you wanted to give, you can give it and create the database. Now click the run button to execute the query. Result will be displayed in the results panel as the test. As I have given this name, database will successfully created, and the following screenshot displays the output processed using SQL. View database. To view all the listed warehouses, user can use the following SQL. It brings the details of all listed warehouses. If we want to show the databases, to clone a database, here we have to user can use the following SQL. Here test db3 is a new database name, while demo underscore is used to clone it. Now create database. If already test db3 is a new data, actually I have created as test dbt. I wanted to clone the database now. So if I wanted to clone the database from demo underscore db, then I will do create database. I have to give the new database name and clone, then old database name, that is demo underscore db. So this is how it will act. Next, coming to the schema. So here, this is how it is performing. Snowflake database. This is about this topic. Next, coming to Snowflake schema. Creating a schema. Same way we have to create, log into this. Now click the databases. It will navigate to database view screen. Then click database name where you can want to create a schema. Here, after clicking the database name, see, we will be having a tables, views, schema, stages, file formats, sequences, pipes. Highlighted one is schemas. So click on schema. Now click the schema icon by default. Table is selected as shown in the following. So it displays the list of schemas which are already available. Now click the create icon over here. So create a new schema as shown in that. So when we click on there, we can provide the details. We should create a table over here, schema name, and then if it is public or private, whatever we want, we can create it by providing the column names like name, type, null or not null, default. So whatever we want to give, we can give here, and we can provide the details, all the details of a table, schema name, a comment. If you want to provide any comment, you can provide over here and click on finish button. Then it will create successfully. After user click the create icon, user will be able to see the create schema dialog box. See here, name test underscore schema. Enter the schema name and click finish button as shown here. So now that is about the schema. I mean Snowflake schema. Here now we are going to create tables and columns. The same way we need to go to database, tables, and then create. So here login, same, click on the database, then it navigates to database view screen. Then user want to create a new table, it will navigate to database properties page. User can see tables, views, schemas, everything. So inside the database, click the tables. If it is not selected, by default table is selected. So user can see the list of tables created in the same database, otherwise it is blank. See here. So next, click the create button to add a table. It will pop up the create table dialog box. Enter the following details. We should give the table name, schema name, column name, and to add multiple columns, keep clicking the add button and then enter details. Now click the finish button. So this is how it works. So this is about this. Now we will discuss about the load data from files. So we have created schema, database, warehouse, everything. We learned about everything. Now we need to load data from the files of Snowflake. So we'll discuss the steps that should be followed to load data into table using a file. So Snowflake supports CSV, JSON, XML, Avro, ORC, Parquet, so on. So dat file, zip file, so all this, I mean, all these files are accepted in Snowflake supports. So this approach is limited to load a small, I mean, this CSV file format loading data approaches a limited data, I mean, small amount of data up to 50 MB. So create a sample file in any of the format. While creating the file, make sure the number of columns in the file and table should match. The number, I mean the number of the columns in the file and table should match, otherwise the operation fails while loading the data. So we should check all those details before loading the data. In test underscore db, I mean, I have given some example like test underscore db dot schema dot warehouse dot schema dot table. So here the db name, schema name, table name, there are 3 columns. So for example, I have provided 3 columns, that is id, name, and address. See the following sample data, id, name, address, and it is CSV file. So this is how it will load. Now click the databases icon. So now click the databases icon present at the top ribbon. Click the table name. So once it is clicked, where you want to upload the data, it shows the number of columns and definition. So the following screenshot shows you everything. This is how it will load. Next, re-verify the sample file. We need to re-verify everything, whether the column is matching perfectly or not. So with respect to columns, click the load table button at the top of the column names. It pop-ups load data box. So load data dialog box. From the drop down, select warehouse, select warehouse name, warehouse, and warehouse name. Warehouse name should be after selecting the warehouse, select warehouse name and click the next button. So on clicking the next button, select a file from a local computer. As we are storing a file in our local machine in a CSV format or in Avro, anything. So once the file is uploaded, user can see the file name. So once the user can see the file name, see here. For example, they have loaded as weekly report. So here in the following screenshot, I mean, click next button. Now create the file format clicking plus sign. See here, file format. We should create the file format by clicking plus sign. Then select file format from drop down and click load. See, click on load. After loading the results, you will get the summary as shown below. See, if the file of data.csv loaded successfully with the rows parsed, rows loaded, and if it is loaded successfully, it will give us green tick. If it is failed, then it gives red into mark. So this is how it, if it is on hold, it will give us 2 lines within green color. So this is how it will takes place. I mean, it loaded successfully, and the load results, it will give a pop-up window like this, and click on OK button. So this is how it acts. To view the data, run the query. So whatever the data is loaded, if we want to view the data, go to the Snowflake UI, and we need to run the query by passing a select query and give a table name. Here we will be given, and user can see the DB schema and table details. See, here we are seeing the data. See, compute underscore HS, test underscore DB, test underscore schema. See, select star from some whatever the table name we have given. We can view into that, and we can go with it. This is how we will load data from files. Next, coming to loading data from a local file. So upload a file into Snowflake stage. See, Snowflake stage, and then a plug-in provided by Snowflake. To perform it, go to help and click on download. See, here we need to go to help. Click on help, download. On clicking download, you will see CLI client over there. Just download, click the Snowflake repository as shown. See, on clicking the CLI client, you will be seeing Snowflake repository over here. Click on done. Then you can move to Bootstrap. So Windows 8664, click to download latest version. We need to download the latest version over here. This is the following screenshot for that. After that, load data into tables and columns. Now install the downloaded plugin. After installation, open CMD command prompt in the system. Then run the following command to check. We need to check the connection, whether this is installed successfully or not. So to view that, we need to run the following command to check the connection. This is NoSQL -a account name -u username. If we give this, we can check the connection over here, whether it is connected successfully or not. It will ask for password. Enter your Snowflake password and press enter. You'll see successful connection. Now use the command line username ash warehouse name at dbname dot schema name. So use this. Now use the following command to upload files into Snowflake stage. Put file. So see users and some file name documents data.csv. The CSV is whatever the file. Don't forget to put the semicolon sign at the end, else it will run forever. So if we are not going to put semicolon at the end, it will run forever. So please do not forget to add semicolon at the end of the command to upload the file into the Snowflake stage. Okay. Next, coming to once the file get uploaded successfully, we need to run the following command. So this is what? To command into worksheet. So copy into testdb. So already the data is loaded from file to Snowflake stage. So what we should do, we need to upload, copy the data from Snowflake stage container to our Snowflake DB. So that for that, what we need to do, we need to use this below command. Copy into, we need to give DB name, schema name, table name from whatever the CSV file or any file is uploaded. So we should give that, and we should give about statement purge is equals to true. Data will be loaded successfully into the specific provided table. So this is about the loading data into tables using SQL process. Now coming to external data load process. Here Snowflake external data, let's discuss about this. Here Snowflake supports, as we discussed earlier, Snowflake supports cloud storage from client side as well. It means the client can have the data in their clouds, right? So as they can load into Snowflake by referring the location. So as of now, as I told earlier, it supports 3 clouds: AWS S3, Microsoft Azure, and Google Cloud. Now, Google cloud platform location. So these are all known as external stages because those are external. And I mean, however, Snowflake provide manages stages that are internal stages. External stages are client side locations. I mean, where internal stages are used when user working with their local system. As we discussed earlier, load the data using files, that is internal. So we did not use any external stage or cloud process to load the data with files. So we used only the internal process. Just we have taken the CSV file before and loaded it into the Snowflake stage, and we did all those things with a file by running some commands and everything, right? But coming to external storage, we need to use any of the cloud here. That is AWS S3, Microsoft Azure, and Google. Any of these we should use, and we should load the data as per our requirements. To upload data from external clouds, so it will be totally a raw data in the cloud. So we need to modify the data as per the requirement. There will be a requirement over here, matrix process. I mean, it should match the column names with the provided client, and we should we should modify all the columns as per the provided client requirement. And we should create a format for that, create a table accordingly. Then we should load the data from the Azure or AWS and Google, anything, any of the cloud support. Raw data first, raw data should be done like this. After that, consider, I'm going with an example, so I'll be explaining or briefing about with the example of each cloud over here which supports Snowflake. So consider the example of AWS. So let's take with AWS first. An existing database, if there is an existing database and schema in the Snowflake where data must load, an external stage setup pointing to the AWS. So we need to set up a external stage in AWS S3. So S3 bucket. A file format, it defines the structure of files. Those are loaded into AWS S3. So here it defines the structure of files. A file format should be loaded into AWS S3. Let's learn about the requirements and load data into tables. First, create a DB name, schema name. If they are not available, please create. These are explained in the previous chapters. So external stage can be set up through Snowflake users interface as well as using SQL. We can set up Snowflake user interface. I mean, that is UI. User interface is nothing but UI, or as well as using SQL queries. So we can set up in a both ways. Okay. Next, using UI to create external stage, follow the instructions. Log into the Snowflake as usual. Click the databases present at the top ribbon. In the database view, click on the database name. Now click the stages tab. Now click the create button present at the top. It pops up create stage dialog box. Select Amazon, I mean AWS S3. So here, this is the one, create stage AWS in the list, and click the next button. So user should enter all these details before loading the data, before for setting up everything. Name, it is the user defined name of external stage. The name, same name will be used to copy the data from stage to table. Okay. Schema name, select the schema name where table resides to load the data. URL, provide S3 URL from Amazon. It is unique based on bucket name and keys. AWS keys ID should be given. Please enter your AWS keys ID. Secret key is also provided to connect through AWS. Encryption master key should be provided. So these are all the details should be mandatory over here. Next, after providing these details, click finish button. So once finish button, following screenshot describes everything. User will be able to see created file format in view panel. Now external data loading using SQL to create the file format. So we need to create the file format because the data, raw data, we cannot load directly to the stage level, Snowflake stage, because we need to follow some format. We should create a file format for that. Once the file format is created, then we should match the column names, tables, everything should be matched before loading the data. Just run the following, provided all the details, and then it will create the file format. Once file format is created and it is successful, data will be loaded successfully to the table. Here, create file format in the SQL command. How we will create in the SQL? Before, we have used only Snowflake UI. We have created a file format in a Snowflake UI format. But here we are creating a file format in a SQL command using a create format in Snowflake. My here SV for CSV format is the name given in the file format, but type is equals to CSV, specifies the format type. Snowflake supports various types like what I told you. Field delimiter, comma specifies the delimiter uses in the CSV file format. Skip header, one indicates that the first row of the file contains header and should be skipped during data loading. So headers should be skipped. If headers are added, so in the already we'll be creating the column names, everything we are formatting the file, right? If we add the headers again, it will duplicate and it will fail to load the data. So that's how it will take place. Skip header is equals to 1, indicates the first row of the file contains header and it should be skipped during data loading. This is how it will. File format options. Snowflake provides a range of options to customize how data is interpreted during loading, such as specifying column types, date formats, skipping blank lines, all these. I mean, we need to check this column names. Column names should match perfectly. Date formats, and varchar. I mean, all those things. Skipping blanks like blank lines, etc. So once a file format is created, you can use it when loading data into Snowflake tables. So it ensures that the data is correctly parsed and loaded according to the specified format rules. So once everything set, I mean, for file format is done properly, it is good to go. Data will be loaded successfully without any discrepancies. I mean, it does not pop up with any issues. If the specific file format user need is not directly supported or available through SQL in Snowflake, there are few alternate approach. I mean, custom parsing. User can write custom parsing logic in ETL. So extract ETL is nothing but extract, transform, load process in our application code to handle file. For example, if user have a complex or non-standard format like a binary format or a custom text format that Snowflake does not directly support, we can write a code to parse the data and transform it to a format Snowflake can ingest, such as CSV file or JSON. So this is how we can do. User use external tools or scripts to process the data into compatible format before loading into Snowflake. For instance, user might use Python scripts with libraries like pandas to manipulate and format data files. See, if it is not, I mean, formatting files is, if we are facing any issues while creating file formatting or for the data files, we can use scripting also, that Python script with libraries like pandas to manipulate and file formats, uploading them to Snowflake tables. So this is how we need to do. Snowpipe with external. Snowpipe is a Snowflake feature that allows user to load data continuously from stage in an external location like an S3 bucket, AWS S3, Azure Blob Storage. If user file format is supported by Snowflake less, user can leverage this automate data loading without need to direct. I mean, if user follows, I mean, continuously from files stage, here we can automate data loading without use of SQL file format creation. This is how it works. Snowpipe works like this. Next, coming to load data. Let's see how the setup all required parameter like stages, file format, database to load from S3. User can run the following query. First, user should run this following query, what all files present in the given stage. So we can list all the files. So now to load the data, run the following query. So copy into database name, schema name, table name from a database name. So we, from where are we running and what is the file name, file format, everything should be given. Now to load the data. Okay, now this is about this process and it will load the data successfully by using cloud, that is AWS S3. Next, coming to the external data loading with an example on Azure. So here, coming to the Azure process, here what we have done, the key integration point between Azure and Snowflake is Azure Blob Storage. So you can see the diagram over here, Azure Blob Storage. Here we will be having, before we load data from Azure Blob Storage, we should define a format. So once we define a format and title for files, it will be loaded and distributed as flat file, CSV, DAT, and zip files. Snowflake expects that any data to be loaded from Azure application into Snowflake's stage, that is raw data. Raw data is nothing but data source. It may be from anything, sales cloud, marketing cloud, or anything, revenue cloud. So from any Google BigQuery or SQL, anything. So data source may be anyone, and this can be created with the ADF pipeline. So first, what we'll do, we'll create a ADF pipeline for a data source. So once the ADF pipeline is created, we'll move the data to Azure Blob Storage. Once the data is moved to Azure Blob Storage, here we will create a file format. Once the file format is created, we'll move the data to Snowflake stage by passing a query. Here, let me show that. Use ELT or ETL methodologies to load the raw data into data warehouse without significant transformations. Implement data validations check to identify and address any issues might rise during the load processing. So this is how it works. Data extract data from GA4 source to blob storage of using ADF pipeline. As I have shown before here, ADF pipeline, and this raw data will be moved to Snowflake stage by passing a query, copy into. So that's first we need to create a file format. Once the file format is created, it will move to Snowflake. Totally a raw data will be moved to Snowflake stage. Snowflake stage will have only the raw data. If we want to have a transformed data, we should create a file format, and a table should be created with all the columns with the as per our requirement. Then we need to check everything has been done properly by creating a file format or not. Once that is done, we should pass a command, that is copy into DB name, schema name, table name, and then we can transform the data. If we want to analyze the data, so we can analyze the data and analyze the data of particular transformed data of a particular tables or databases. Then we can, what we can do, we can go for a, what is that, we can analyze the data and we can extract the Power BI report. So this is how we can do. Reporting BI tool can also be implemented. Power BI report can also be implemented on the transformed data as per our requirement. So this is how we follow. We will load the data and report. We will extract the report using Power BI or any other tools. Whatever the tools required as per the organizations, they can follow the same for this. So this is how we will follow. Next, consider an example of GA4. So GA4 is also the same way, blob storage using ADI. First, we'll have the ADF pipelines for the particular data source. We'll create that, and we'll be having that ADF pipeline to Azure blob storage, and then copying the data from blob storage to Snowflake stage using copy query by automating with the SnowPipe. Raw data is loaded to respective tables and raw data is modified. We can use the DBT tool as well, database tool. So that tool can be also used and we can transform the data, Power BI to analyze and visualize the data. So this is how we'll go on. So here in these ways, we load through external data loading, load the data internally by using files. So this is how we follow and will do it. So this is my demo and my session. Thank you for your opportunity. Thank you. Any questions? David?
Hi, Avanti. We don't have any questions today.
Okay.
So I'd like to thank you for that in-depth session.
Yeah.
And thanks to everyone who watches this video. If you have any question in the future, you can still add it to the video and I will pass it on to Avanti.
Yeah. Thank you, David. Thank you. Thank you
Okay.
so much.
Thank you, everyone.